Hello everyone. Welcome to today's session on light, reflection and refraction. So today we are going to look at the image formation by spherical mirrors. So in previous session we learned about the spherical mirrors. Those are concave and convex. So now let's see how the images will form using those concave and convex mirrors. To do that, first let's review the ray diagrams. Okay, so here on the left side, this is the concave mirror, and the right hand side it is the convex mirror. So this is the concave and this is convex. So let's understand the ray diagrams, right? So let's look at a ray parallel to the principal axis. So this is the principal axis, and this is the center of curvature, and this is the focus, and this is the pole P, okay, or center of the mirror. Now, if a ray parallel to this, if a ray parallel to the principal axis falls onto the, this is concave, right? So falls onto the concave mirror, then what happens is, so we know the angle of incidence equal to angle of reflection, right? So if we draw an imaginary line from the center to the point of incidence, then this is the angle of incidence I, and then with the same amount of angle, it will reflect back, right? So it will reflect back and pass through the focus. So this is the refracted ray, and this angle is angle of reflection. So what happens is, if a parallel line to the principal axis incidents on the concave mirror, it reflects and passes through the focus of the concave mirror. So that's one scenario of the ray diagram. And similarly, what happens if the same ray parallel to the principal axis falls onto the convex mirror? So let's look at this. So this is the ray parallel to the principal axis, and if this ray falls onto this convex mirror, so same thing, like the angle of incidence and the angle of reflection we need to see. So if we draw a imaginary line to the center of the to the center, then this is our angle of incidence, right? So this is our angle of incidence. With the same amount of angle, the ray gets reflected. Let's say it is reflected like this. So this is our angle of reflection. Now, if you extend this ray, it will appear that it is going away from the focus. Okay, you understood? So what happens in concave mirror, if a ray parallel to the principal axis incidents on the concave mirror, then it reflects and passes through the focus. Similarly, in the convex mirror, if a ray parallel to the principal axis incidents on the convex mirror, it reflects back into the same medium, that is into the air. But if you look at that, that appears to be coming out of the focus of that convex mirror. So this is the ray diagram in the case of parallel to the principal axis. Now, let's look at a ray passing through the principal focus. So what is this mirror? This is concave, and this is convex. Now, what ray diagram we need to see? A ray passing through the principal focus. Okay, so what happens if a ray passes through the principal focus and incidents onto the concave mirror? So this is the ray, incident ray, and it is going through the focus, and it is inciding on the concave mirror. Now let's join this center and that point of incidence. Then what you will get the angle of incidence. This is I. So with the same amount, this ray reflects back, but it reflects back parallel to the principal axis. So this is our angle of reflection. You understood? So if a ray passing through the focus incidents on the concave mirror, it will reflect back into the same medium as a parallel line to the principal axis. So this is P, guys. Yeah, this is P. The the pole of the mirror or the center of the mirror. Okay, so what we learned here, so a ray incident on the concave mirror through the focus that reflects back into the same medium that will go parallel to the principal axis. Okay, similarly, let's look at this now. Let's look at the convex mirror. So what we need to do is we need to have a ray that appears to be going through the focus. Okay, yeah. So I'm drawing with free hand, so will not get as a straight line. But yeah, okay. So this ray is incident and passing through, appears to be passing through the focus. Now, if you join a line, imaginary line, to the center of the curvature, right? So what is this? This will be our angle of incidence I. Now, with the same angle of reflection, this ray will reflect, and this goes parallel to the principal axis again, and this will be our angle of reflection, that is I equal to R. In every case, in a mirror, I equal to R, even in the previous case, right? So I is R. I is equal to R. Angle of incidence equal to angle of reflection. So far what we learned two scenarios. One is a ray incidenting parallel to the principal axis that will reflect through the focus in both the cases. And similarly, now we are looking at a ray passing through the focus that will reflect parallel to the principal axis. So these are the two scenarios we have covered. Now let's look at this. A ray passing through the center. So what will happen if a ray passing through the center? So this is P, the center of the mirror. This is also P. So this is which mirror? This is concave mirror. And what is this? This is convex mirror. All right. So what scenario we are covering now? A ray passing through the center. So let's say I have a line that is passing through the center, and incidenting on the concave mirror. So what happens here? So the angle of incidence here is 90 degrees. And what is the angle of reflection? That also should be 90 degrees. That means this ray travels back in the same direction, reflects back into the same direction. Here, I equal to R, that equal to 90 degrees. Right? Not 90 degrees, guys. This is 0, right? What is the angle of incidence? The angle that it makes uh, with the normal, right? The normal is from C to the point on the mirror. So this is 0 degrees. Okay, so this is 0 degrees. So I equal to R equal to 0 degrees. So the ray reflects back in the same direction. Okay, this is important, guys. When an incident ray passes through the center of the curvature, and incidents to the mirror, it reflects back in the same path of incident. So here, both the incident ray and the refracted ray both are same. Okay, now let's look at this scenario in the convex mirror. What will happen in the convex mirror? So it is same in both the mirrors, right? So this is an imaginary line. Let's say this is the ray that is the incident ray that is incidenting at 0 degrees. So here also I equal to or equal to 0 degrees. And then it reflects back in the same direction. But when you see, it appears to be incidenting and also reflecting from the center of the curvature of that convex mirror. Okay. All right, guys. So this is the ray diagram for a line passing through the center. Now let's look at this. A ray incidenting obliquely at pole. So what is the pole? This is the P. This is the pole or the center of the mirror. Now, if a ray is incidenting at some angle, right? So with free hand, so bear with me. So this is the angle of incident. So what will happen? This is the normal, right? The line passing through this is the normal. So with the same angle, it reflects back into the same medium. So this is I, and this, this is incident ray, right? This is incident ray, and this is reflected ray, that is R. So in this case also, I equal to R. So what will happen here if a ray on the convex mirror, right? So this is also same. So what happens here is it reflects into the same medium, and this is our angle of incidence, and this is our angle of refraction. Sorry, reflection. So I equal to R. So this is concave mirror, and this is convex mirror. So these are the ray diagrams. There are 4 scenarios that we covered. So let's do a quick review. So when the line incidents parallel to the principal axis in both concave and convex mirrors, it exits or it moves. It reflects from the focus of the mirror. You understood, right? And then the other scenario is if a ray is incidenting through the principal focus, then it will reflect parallel to the principal axis. That is in both the cases. Now, what happens if a ray is passing through the center? So it reflects back along the path of incidence. Okay, because here I equal to R equal to 0 degrees. Next, now a ray incident obliquely at pole. So with the same angle, it will reflect into the same medium in both concave and convex mirrors. Now, with the help of these ray diagrams, now we can determine how the images are formed in both the mirrors, concave and convex. Now, let's first focus on concave mirror with the different positions of the object. Okay, so here the first scenario we are covering, the position of the object is at infinity. So let's say somewhere here, right? Somewhere here, there is an object. Okay, let's say AB is an object that is very far, infinity, right? And now, if a ray of light from this object falls onto the concave mirror. So what happens? A line is coming parallel to the principal axis. So this is P, guys. Okay. So what will happen? The reflected ray should go from the focus. So this is how it reflects back. Correct? And now let's say from B there is a incident ray, light of ray falling onto the concave mirror, and this is also parallel to the principal axis, so it should also reflect from the focus. So basically what is happening here? So the image is forming at the focus. So what type of image this is? This is like a very much highly diminished, and we can also call it as a point image. Okay. And the image is forming on the same side of the object. So we can say this is a real image. Okay. So you understood these, guys. So we have an object AB, and I just draw 2 rays, one at A, one at B, that is incidenting onto the concave mirror. As per the ray diagrams we just learned, this parallel ray reflects from the focus. The reflected ray will go away from the focus, through the focus, right? So at infinity, if the position of the object is at infinity, what is the position of the image? The position of the image is at F. Correct? So when the object is at infinity, the image forms at F. And what is the size of the image? The size of the image is highly diminished, right? It is just like a point image, highly diminished, and we also call it as a point image, right? Hope you guys are following, right? And then what is the nature of the image? The nature of the image is as it is forming at the same side of the object, same side to the mirror, we can say it as a real image. And what is its position? It is basically inverted. So yesterday I gave in the previous session, I gave an example of a spoon, right? If you look at the spoon, your face on the concave side and on the convex side. When you look at the concave side, you will see your image inverted, okay, upside down. So in a concave mirror, all the images that we get are inverted and real images. Understood? Okay. Now let's look at the next scenario. Now, this is the object is beyond C. So beyond the center of aperture, center of the curvature actually, right? So let's say I have an object AB, right? AB is my object, and it is falling, a parallel ray is falling onto the concave mirror, So how it should go? It should reflect from the focus, right? So this is the reflected ray. Now, what happens if a ray is passing through the center? What will happen? The reflected ray should also come out from the same direction, right? So if this is the incident ray, this is also reflected ray. Then where these two are meeting? These two are meeting at this point. That means that is our A dash. So that is our object top. And then if I draw a projection to that onto the principal axis, then that is B dash. So now A dash B dash is the image. So AB is the object and A dash B dash is the image. You follow, guys? Now let's fill this table, right? So now we understood. So for this image formation, you can take a parallel ray and then that passes through the focus, the reflected ray, and one ray you can take from which passes through the center. Yeah, that you can do. Or you can also take a ray that passes through the focus. Okay, any two rays are sufficient. Okay, now if I place an object beyond C, what is the position of the image? The position of the image is between C and F. That's what we got it, right, guys? Between the center and the focus, between C and F. And then what is the size of the image? The size of the image is diminished. It's not highly, but it is diminished. It's not the same size. It is slightly lesser than the original object, right? Then, yeah, size of the image is diminished. And what is the nature of the image? So it is forming on the same side of the mirror. So it is a real image and inverted, right? It is real and inverted image. Okay, so that's about this scenario. If we have an object beyond C, we get the image between C and F, and it is diminished and it is real and inverted. Okay, let's move to the next scenario. What happens when the object is at C? So when the object is at the center of curvature, what will happen? Okay, let's take any two ray diagram. So I will put an incident ray parallel to the principal axis. So ideally it should go, the reflected ray should go from the focus. Now, what happens if I have a ray passing through the focus and incidenting onto the concave mirror? So it has to reflect back parallelly. 1 minute, guys. So let me draw it properly. So consider the second line. So basically what happens is the image is formed, which is like A dash and B dash. So this is AB. So this is A dash B dash. So AB is the object here, and then A dash B dash is the image. So basically, where are we getting this image? We are getting that image at the center and it is of same size. Okay, so that's the scenario. Like when the object is at C, the position of the image is also at the center of curvature. What is the size of image? Actual. It is the actual or exact size. So it is not diminished. It is the same size of the image is formed. And what is the nature of the image? It is forming to the same side. So it is still up. So I guess. So it's actually a real image, right? It is a real image and inverted. So in this scenario, when the object is at C, at the center of curvature, we get the image also at C of same length, right, of the same size, and it is real and inverted. Okay, now let's move to the next scenario. In this scenario, the object is between center of curvature and the focus. Okay, let's see. So if the image is between C and F, so I put an incident ray parallel to the principal axis. So the reflected ray should pass through the focus. Right? Now, should pass through the focus. So that's one scenario. And then one minute, guys. Okay. Now let's take another ray, right? So this is AB, right? This is AB. So where the incident ray is incidenting parallel to the principal axis, and it is reflecting from the focus. Now, let's take another ray, right? So that's, let's say there is another ray that's incidenting through the focus. So if it is through the focus, what will happen? This ray, so this will reflect parallel to the principal axis. So then what is happening here? So this is our A dash, B dash. So this is A dash and this is B dash. So what is happening here? So the image is when the object is between C and F, we are getting an image that is beyond C, right? Is that true? So we are getting an image which is beyond C. And what is the size of the image? This is enlarged. And what is the nature of the image? It is real and inverted. So what is the position of the image? The position of the image is beyond C. And what is the size of the image? It is enlarged. So we are seeing a magnified image when the object is between C and F. And what is the nature of the image? Nature of the image is real because it's forming on the same side, and also it is inverted. Right, guys? So here AB, what is AB? AB is our object. And then what is A dash B dash? So A dash B dash is the image. All right. So let's move to the next scenario at F. So what happens if the object is at F? At the principal focus itself. Let's say this is AB. AB is the object. Then what happens if I pass a parallel ray? So what will happen? It has to come through the principal parallel, sorry, it has to pass through the principal focus when a parallel ray incidents onto the mirror. Now, if if a ray parallel to the, if a ray is incidenting from the center, then what will happen? It will reflect from the center. So I have taken here two rays. One is the first ray incidenting parallel to the principal axis. So it is, the reflected ray is passing through the focus. And then I have taken another ray that is incidenting through the center, and then the reflected ray should also go in the same direction through the center. Then if you see, I am getting this image at infinity. So they never interact. I mean, they never intersect. These two lines never intersect. So when I have an object at F, we will get image at infinity, right? So what is the position of the image? The position of the image is at infinity. And what is the size? The size is, there is no image formed actually here. Okay, the position of the image is at infinity and we cannot see that. Okay, so we can say like no image. Okay, so as there is no image, we cannot say how much size it is and what is the nature of the image. Okay, so when the object is So AB is the object. So when the object is at F, the image is at infinity. We can say there is no image because we cannot see at infinity. Right. Then there is another scenario where the object is between F and P. So this is P, right? Our center. So let's say I have an object here which is at between F and P. So when the object is between F and P, what will happen? So I will put a ray that is incidenting with some angle of incident. So what will happen here? This has to reflect like this, right? If this is I, this is R with the same angle. Now, I also can see like, yeah, if I will take a ray that has to incident through the center. So what will happen if the ray is incident through the center? It will also reflect through the center. Then where the image is forming. So these two lines are not going to interact this side of the mirror, right? If I extend this will go like this, and this will go like this. These are not intersecting. What happens if I project these to the back side of the mirror? So let's say I am extending the principal axis. So what is happening here? It is meeting somewhere at the back of the mirror. So if I put a straight line here, if this is my object AB, then this is A dash B dash. So what is happening here? It is a virtual image is being formed in this scenario. A virtual image is getting formed behind the mirror, which is not to the same side, and it is also erect image. It's not inverted. So this is the only scenario in concave mirror where you will get a virtual image. So what is that scenario? When the object is between F and the center, then the position of the image is, what is our position of the image? That is actually it's a virtual image. So that is behind the mirror. Okay. So it is behind the mirror. The image is behind the mirror. And what is its size? Its size is enlarged. It is bigger than the actual of the object. So it is enlarged. And what is the nature of the image? The nature of the image is virtual. So this is the only scenario in the concave mirror where you get a virtual image. So it is virtual and it is also erect image. So in all the scenarios that we look at the image formation for concave mirrors, we got all real and inverted images to the same side of the mirror. So this is the only scenario where we will get a virtual image, virtual erect image behind the mirror. So the position of the object should be between F and P. So these are the various scenarios, guys. Okay. So let's do a quick recap, right? The all the scenarios that we have. So if the image is at infinity, we are getting a point image at the focus, and it's a real and inverted image. And when it is beyond C, when the object is beyond C, we are getting a diminished image between C and F, and it is real and inverted. And what happens when it is at C? We'll get the image also at C, and that's the actual or the exact size of the object, and it is also real and inverted. And now what happens if the object is between C and F? We are getting an image which is beyond C, that is enlarged, real and inverted. Now what happens if the object is at F? So we'll get the position of the image is at infinity, which we cannot say like what is the size on the nature of that image. And what happens if the object is between F and P? It is behind the mirror. This is the only this is the only special scenario where we get virtual image using the concave mirror. Okay, so let's summarize here, guys. So this table is from your textbook. So this summarizes what is the position of the image and what is the position of object and the position of image and the size of the image and also the nature of the image. Okay. All right. So now let's look at what are the uses of concave mirrors. So I think in previous session, I already explained you. The concave mirrors are commonly used in the torchlights, also searchlights, and also some headlights of the vehicles to give the parallel beams. Okay, that's one thing. And then they are often used into the shaving mirrors, right? The mirrors that we use to give us the magnified image, right? When we put our shaving mirror close to us, so we can see a magnified image of our face. So in the shaving mirrors also we will use concave mirrors. And similarly, the dentist uses concave mirror to see our teeth as a enlarged or magnified image. And then there is another use case where the large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. So basically what a concave mirror does, if a parallel beam of light falls onto the concave mirror, it converges everything to the principal focus. So at that point, you can generate the maximum amount of heat. So that principle is used in the solar furnaces to produce heat. All right, so that's about the image formation on concave mirror, guys. So now let's move to the convex mirrors. So let's see how the image forms in convex mirrors. So in the convex mirrors, I have a position of the object. Let's say I have an object at infinity, right? So this is the convex mirror, right? So because the outside of the mirror is where the rays fall, the inside of the mirror is polished, means it will not allow light to pass through inside. So let's say this is my image AB, and if a light ray falls onto the convex mirror, which is parallel to the principal axis, what will happen? It appears to be going from the focus. So it reflects into the same medium, but it appears that it is reflecting from the principal focus. Similarly, what happens if a ray from point B incident parallel to the principal axis? Yeah, this is also same. Like it reflects into the same medium, but it appears that they are coming out of the principal focus. So here, what is happening is what type of image is forming here. So when the object is infinity, the position of the image is at F. And what is the size of the image? It is highly diminished or highly diminished, or we can also call point object, right? Point size image. And what is the name or nature of the image? It is which side of the mirror it is forming? It is forming behind the mirror. Behind the mirror means it is a virtual image. It is a virtual image and erect. We will see in the next scenario, are we getting what type of image it is? It is basically an erect image. Okay, guys. So it's a highly diminished point sized image and it is behind the mirror. So it is virtual. If it is same side of the mirror, then it is real image. Okay. So this is in the convex mirror, the first scenario where the object is at infinity. So you'll get the image at F, and that is virtual image, and it is highly diminished or point sized image. All right, guys. So let's move to the next scenario. Here, the object position is between infinity and P, somewhere. Let's say somewhere here. So if I can extend this principal axis, right? So the image is somewhere at infinity and the center, which is P. If the image is here, okay, so let's incident a ray which is parallel to the principal axis. So it appears that it is coming from the, it appears that it is reflecting from the principal focus, right? Now, what happens if a ray incidents like this, right? If a ray is incidenting through the center, I'm trying with freehand, guys. Okay. So if a ray is incidenting through the center, then it also reflect through the same path, right? So where these two lines are joining, these two lines are joining here, guys. Oh, hold on. So these two lines are joining here. That means this is my A dash and B dash. So where this is forming behind the mirror. That means it's a virtual image. And what is the size of the image? It is smaller than our original object, right? So AB is the object here. So AB is the object, which is bigger, and A dash B dash is our image, which is appearing like a smaller than our object. So that means it's a diminished image and forming behind the mirror. So that means it is virtual and it is standing, right? It is above the principal axis. That means it is an erect image. So what is the position of the image? The position of the image is between P and F, right? It is between the center of the mirror and the principal focus. And what is the size of the image? Size of the image is diminished. So the size of the image is diminished. And what is the nature of the image? So the nature of the image is forming behind the mirror. So it is a virtual image, and the position is, it is basically a erect image. Okay, so that's about the convex mirrors. So there are two scenarios in the convex mirror. One is if the object is at infinity, we'll get the image at F, and it is highly diminished or point size image. And the nature of the image is virtual because it is forming behind the mirror. Similarly, the other scenario, if the image is anywhere between the center of the mirror and anywhere on the principal axis, then it is getting the image formed behind the mirror. That is so virtual image, that's an erect image, and that is smaller in size than the original object. So it is diminished image, and it is forming between P, the center of the mirror, and the principal focus. Understood, guys? All right. Now, let's summarize. So there are only two scenarios. So when the image is at infinity, we are getting the image. When the object is at infinity, we are getting the image at F. It is highly diminished, point sized, or virtual and erect. So in convex mirror, in both the scenarios, we get a virtual and erect image, right? So the second scenario where the object is between infinity and P, then we are getting an image between P and F, and that is behind the mirror. So it's a virtual and erect, and it is smaller in size. So it is a diminished image. Now let's look at the uses of the convex mirrors. So here the convex mirrors are commonly used as rear view mirrors in vehicles, guys. So this is important. The main application of convex mirrors is we use as side mirrors to the vehicles. So how this helps? So convex mirrors are preferred because they always give erect image. So what type of image we need, guys? In the mirror, in the side view mirror, we need an erect image, the same image, right? If we use a concave mirror, what will happen? We'll get an inverted image. So that means we will see the vehicles upside down. That creates more confusion than actually helping. So we need a erect image, and also a virtual image we want to see. That virtual image we should see in the mirror, I mean the behind the mirror, and erect image. So the key feature of these convex mirrors is to produce a virtual and erect image. So these mirrors are preferred. Convex mirrors are preferred because they produce the erect and virtual images. So thus, convex mirror enable the driver to view much larger area than would be possible in a plane mirror. So we can use the plane mirror also, but why we are using these convex mirrors is like it covers more area and converges that. So it basically converges a larger area into that smaller mirror. So if we use plane mirror, what happens? If we use plane mirror instead of convex mirrors, in a plane mirror, you see exact size, right? You see exact size, and also you will see at same distance. You will see at same distance. But in convex mirror, even if the vehicle is very far, the image appears to be closer. That means you will be alert because the vehicle appears that it is close to you. So either you give way to the vehicle, or you will maintain the same speed, or even you will accelerate so that that vehicle will not come and hit you. Understood? So the main reason that we use convex mirrors are it produces erect image and virtual image. And the other use case is it covers a larger area behind our car or vehicle and puts that into that mirror than the plane mirrors. Okay. In plane mirrors, it will not cover larger area. It just covers a smaller area, and that smaller area is not going to helpful because the image is seen exactly at the same distance than what actually it is. Right. So that's not going to help us. So we need to get alert before that vehicle comes closer to our vehicle. So that's why we use convex mirrors where the image at a distance can be seen as a closer image and more area is covered. So that's the reason we use convex mirrors. So, all right, guys. So I think we have looked at the ray diagrams and how the images are formed in both concave mirrors and convex mirrors, and a summary of the table, and also what are the uses of concave and convex mirrors. So that's all for today's session, and I hope you all understood the topic, and I will see you next time. If you have any questions or queries, you can reach me using my Urban Pro profile. Thank you, guys.